From the app you just scrolled through on your phone to the massive systems that, well, run our entire cities, software is literally everywhere. But have you ever stopped to think about the blueprint behind it all? Today, we're going to pull back the curtain on the incredibly structured discipline that makes our entire digital world tick. So, yeah, how is this stuff really built? I can tell you the answer is way more complex and honestly way more interesting than that old stereotype of some lone coder hammering away at a keyboard in a dark room. It's a disciplined, collaborative effort, and that's exactly where we're going to start. And that brings us right to our first big idea. We've got to get one thing straight from the very beginning. Software engineering is so much more than just writing code. See, at its core, it's all about applying proven engineering principles to the entire life of a piece of software. We're not just talking about the moment it's created. This is a whole journey, from that initial spark of an idea, through all the design and development, rigorous testing, and all the way to long-term maintenance and evaluation years down the road. And this brings up a really critical distinction. What's the difference between a software developer and a software engineer? Well, you can think of it like this. A developer might be laser-focused on the technical stuff, writing the actual code, but the engineer? Their role is much broader, much more strategic. They're the ones zooming out to see the whole system, managing teams, talking with clients, and even keeping an eye on the budget. This level of complexity just completely changes the game. I mean, modern software is simply too huge for one person to build by themselves. The source material puts it perfectly. We need teams of specialists. You've got to have designers, analysts, coders, testers, all of them working together perfectly in sync. That idea of the lone genius coder, yeah, for the most part, that's a myth. Okay, so if it's not just about writing clean code, what actually makes a piece of software good? Well, it turns out there are these universal principles that define quality, no matter what the program is supposed to do. Let's break them down. There are 4 big ones. First up is acceptability. Think about it. A banking app might be super secure, but if it's so confusing that you can't figure out how to transfer money, it fails. It's not acceptable. Second, dependability and security. This is absolutely non-negotiable for software running a power grid or an air traffic control system, right? It just has to work. Third, efficiency. We've all used that one app that just drains your phone's battery in an hour. That's what inefficient software does. Good software is smarter with resources. And finally, maintainability. This one's huge because software is never really done. It always needs to evolve. Just think of all those updates you get on your phone. Good software is built for change right from day one. We've kind of touched on this already, but it really deserves its own moment in the spotlight. Given the massive scale and complexity we're talking about, collaboration isn't just some nice to have. No, it's the fundamental engine that drives all of modern software development. So what does a great team actually look like? Well, it's a mix of different skills. You need that core engine of efficiency and creativity, for sure. But that engine runs on the fuel of trust and really clear communication. When everyone feels like they're involved and is committed to the exact same goal, you create a team that can handle anything. And these aren't just feel-good buzzwords. In a high-stakes project, these are the pillars that literally keep the whole thing from falling apart. Okay, so if teamwork is everything, how do you actually engineer it for success? I mean, you can't just throw a bunch of talented people in a room and hope for the best. Nope. You build a system with clear, distinct roles for everyone. This is how you turn a simple group of people into a well-oiled machine. Each of these roles covers a critical function. You've got the facilitator who steers the ship, and the technical expert who helps clear any roadblocks. The secretary and timekeeper make sure you're on course and on schedule. And then the resources coordinator and the checker protect the quality of the work itself. Every single role is vital, even the wild card, who's like the team's super flexible problem solver. So, with a well-structured team in place, what's next? You need a map, a master plan that everyone on the team can see, understand, and follow. And that's where a really key project management tool comes into play. And one of the absolute best tools for creating that map is called the Gantt chart. In just a single glance, it gives the entire team a clear visual picture of the project schedule, who's doing what and when they're supposed to do it.
What makes it so powerful is how it breaks down all that complexity. You can see every single task, but you also see the crucial dependencies, how one task falling behind can cause a whole domino effect down the line. Milestones act as big checkpoints to keep morale and progress high, while assigning owners to each task means there's clear accountability. And then tying it all together are the timelines, making sure everyone is working from the very same clock.
Because ultimately, this is the whole point. A solid plan, visualized clearly, is what allows a team to hit its targets on time and use its resources wisely. It's how you transform what could be total chaos into a clear, actionable strategy.
All right, let's bring it all home. What are the big takeaways here? First, remember that software engineering is a huge strategic discipline that goes way, way beyond just coding. Second, success really hinges on effective teamwork, where everyone has a clear, defined role. And third, structured planning gives you that essential map to get to the finish line. And what's really cool is that these principles, they're not just for software. You can apply them to almost any complex project you can think of.
So, we'll leave you with this to think about. When you look back at any team project you've been a part of, at work, at school, anywhere, and you look at those roles we talked about, the facilitator, the expert, the timekeeper, which one do you naturally fall into? It's kind of a fascinating way to see how the blueprint for building great software might just be a blueprint for building all sorts of great things together.